So just a friendly reminder, if you're looking at the calendar for this unit, it's going to go fast, and that's why I want to make sure you see it, okay? So we're going to design our lab tomorrow, check in on Monday. We're going to do another check-in on Tuesday that's based on the stuff we're doing Friday and Monday, review Thursday, and then we're testing next Friday. So we'll figure that out, okay? Okay? You guys with me? It's going fast because we got to get one more unit in yet before the end of the trimester. So got quite a bit to do. All right, today we are going to do a quick warm-up problem. We're going to review some stuff from Unit 3 because it is absolutely relevant to what we're doing today. And then we'll do Standard 5.1. And at the end, last 10 minutes or so, you'll get the test back that you took 2 days ago. Okay? If you do not have a warm-up sheet, then you can go up and get one. They're up here. Otherwise, pull your warm-up sheet out. If you want a fresh one for Unit 5, that's a great idea as well. Get your warm-up sheet out. I'll put the question up really large so you can see it and give you just a couple of moments to think about it. Okay, so I love the fact that I've heard some good conversation here, some debates. Well, it depends on where you cut it. I don't know. So here I'm going to give you a little visual to help you make a determination. So there's a visual for you. So here we're looking at it. You're looking at it from above. Okay, this dot is the yo-yo, and the yo-yo is going around in a circle like this. The question is it going to follow the path A, B, C, D, or some other path that I have not imagined? Okay, I'm going to give you one more minute. Talk to your table mates. Figure out which way it's going to go. Go, go. All right, friends, you ready to vote? Yeah? Raise your hand if you think the path is A, that it's going to follow a curve like A. Put your hands up in the air. I want to see them. It's awesome, and I want you to see. I want to see where. So A would be like it's going in a circle, and it's just going to kind of continue, and then eventually we'll straighten out. Yeah? Okay. So we got a few votes for A. Awesome. Raise your hand if you think it's B. It's going to go as B travels. So B kind of goes in the same path as A, but instead, what's the difference between A and B? Let me ask you. What's the difference between A and B? What's that? B is straight. So why did you vote for B? Can you tell me what about B made it more attractive than A as an answer?
Instead, like for A, there has to be like some like acting on it to make it like change direction, kind of, because it's curving.
Okay, I'm gonna write that down. The wording was good there. I just want to make sure that I heard what you said. So you said for A that there would have to be what? Something acting on it. Because it's curving up after it's cut. Okay, I'm not necessarily saying I agree with him. I just tried, like the wording there was good. And you're like, it's on freeze. There you go. Looks like I wrote really fast. Yay for me. All right. Go for C. Who's got C? I heard a conversation over here that you guys thought that C was ridiculous. Is that what I gathered from the conversation?
I don't know.
Milo, do you want to speak to that? What I don't remember. I heard the conversation.
I don't think I even said that.
No. Ben, did you say that? Somebody said something like that. I think you're just throwing him under the bus. Nobody thinks it's C? How about D?
Oh, we said that one was ridiculous.
Oh, you thought D was the ridiculous one. Why do you think D is the ridiculous one?
Well, just like envisioning it in our head, it would I don't know, like there was no actual science behind it. It was more of just like a joke. Just like imagining it spinning around, then you cut it and it just goes
straight out. Yeah. So today, one of the things that we're going to talk about is a lot of different kinds of circular motion things. And I want you to remember how Milo reacted to this, and not just his reaction, but the fact that based on what I'm kind of hearing from you, you all think that this is kind of ridiculous. Is that true? Is there anybody that wants to advocate for D? No? Okay, so I just want you to remember that. I want you to remember that you think that D ridiculous, absurd, right? I mean, like it couldn't even be. I just want you to remember that before we move on too far. I want to show you. So we knew we were going to do this this warm-up problem, and so before you guys got here today, Mr. B and I, we tried it out. Okay, we didn't actually cut the string because this is my special yo-yo. I bought this at the dollar store about 12 years ago for $1, and it has lasted me a long time. So I didn't want to cut it, but he made it go in a circle, and we let it go, and we did it in slow-mo because why not, right? So take a look up here. Let's see what happened. Oops. Oh no, close. No, you have to play though. Why is it not going to go? Seriously? It literally just worked before. What in the world? Hold on just a second. Please hold. Talk amongst yourselves for just a moment. Let's try this again. All right, let's see if we can get it to go. See there, now there's a video. I don't know if you can. We were not super clever / amazing enough to make sure that it lined up with the picture. That was a missed opportunity, but you get the idea. So I stood on this table and we did it from above, and so you can kind of see the yo-yo there. We snipped it so it was just the circle and release. So here you go. Oh, come on, now don't not play. There we go. What'd you see? You want to see it one more time? It was not D. Okay. So now I want you to look at the pictures again. Which one is the right one? A or B? Was that you, Corey, that said that? Max? What one did you vote for? Why? What did you see in the video? What did it do? It went straight out. It did. Now, when I watched the video, we're going to watch it one more time. When I watched the video, I was like, what? Because the string kind of follows in a funny way because strings are goofy. And so I wonder, so watch the yo-yo itself, not the string. We're going to watch it one more time. Now that's probably not going to work. Oh, there it goes. Okay, good. Here it goes. So if you watch it, right there is where he lets it go. And do you see? It goes straight up. Yeah. So the string had to like follow it along. So that was a little bit funny. But yes, indeed. The correct answer is B. Okay. I want to give you one word that goes with this, and then I'm going to give you a minute to kind of write some things down. How many of you have taken geometry? Yeah. In geometry class, there's one of these words that you learn in geometry that you don't really realize matters until you get to physics, because it's just one of those millions of words that you learn. So you know about circles, right? You guys have learned about circles. You know this is a circle. And you know that this line here is called the what of the circle? That's the radius. That's not the funny word, because that one you use a lot, right? So there's the radius. And then this line, this blue line, how is it related to the radius? It is perpendicular. Do you see how it's perpendicular? Like it's very much of a 90-degree angle. Bam. Oops. And does anybody remember what we call this line that happens to be perpendicular to the radius? And indeed is always perpendicular. I heard it. Tangent. Yes. This is a good word to know, okay? This line is tangent to the circle. And indeed, we call the velocity that this object has that's going around, we call it its tangential velocity, okay? So the object has, we call it the tangential velocity. So that's the velocity that it has, and if you cut that string, it's going to go off at that trajectory. Okay. We just talked about a lot of stuff, and some of you are trying to write things down feverishly and whatever. I'm going to give you 2 minutes of pencil on paper time. I want you to write down all of what we just talked about in your words so that you can remember it. Does that make sense? I will leave this right here so you can look at it. You can talk about the video. You can draw this picture if you want to, whatever it works. But I need your pencil on your paper or your stylus on your computer or whatever it is so that you're taking notes and thinking about what's going on, okay? I'm gonna give you 2 minutes. This is quiet, you and your brain doing physics time, okay? Go ahead and do that. That you have a place to write it down. So I'm gonna get myself a new page. You might wanna get yourself a new page as well. We're just gonna review a couple of things from Unit 3 that are very important to know for the stuff moving forward. I gave you a purple sheet and we'll do that in just a second. I just didn't wanna have to like pause again. Looking at that purple sheet, you may have thought I got confused and thought that we were back in Unit 3 because it looks kind of familiar perhaps, right? You've seen charts like that before? I'm going to tell you a secret. Unit 5 is really just Unit 3 going in a circle instead of a straight line. That's all it is, okay? So if you got Unit 3 down, this is going to be pretty great. If you didn't, this is an opportunity for you to learn it because you're going to get to do it again on the final if you want to. So it's all there, okay? You've got lots of chance. You got to remember what Newton's first and second law was. I'm going to be super impressed if I ask, does anybody remember what it is? And you can just recite it for me. Does anybody remember what it is? They can just recite it for me? It's like, yeah. Got it? The first and second, it's all one law. Okay. Hey, look at that. This kid, the impulse momentum theorem and conservation of momentum are a repackaging of Newton's first and second law. I would 100% agree. I want to go way back in time, though. You're exactly right. That's true. I want to go back to the like acceleration version of it, though. Is that okay? Okay, so I'm going to do that. But what you said is 100% correct. I'm going to write it out this way. You write it out with me, and then we can fill it in together. If the net force acting on an object in a particular direction is equal to 0, what do you know for sure about that object and its motion? What'd you say? It's not accelerating. The acceleration in that direction is also 0. Okay? Is it possible for the object to be moving? Sure. Sure, the object could be moving. So object may be at rest or moving. But if it's moving, what do we know about its velocity? It's a constant velocity. You got it. And hey, by the way, what does constant velocity mean? What does it mean to have a constant velocity? Make it loud. Make it loud. Talk about physics. Go, go. How are we doing back in my back table? Did you come up with an answer? Can I ask you? Is that okay? Yeah. I'll give you the first crack at it. Is that okay? And then if it's not, if you don't have it all, it's all good. So the question is, my friends, what does it mean to have a constant velocity? What does it mean? It doesn't speed up or slow down. That's right. I agree that if the velocity is constant, it's not speeding up and it's not slowing down. There's one other piece that goes with that, though. What's the other piece? Yes. Yes. So velocity, remember, way way back in the year, we said the velocity was, it was the speed, but it also included the direction, right? So it's not speeding up, it's not slowing down, and it's not changing direction. And that would be something worthy of highlighting or underlining or putting glitter pen stars by or whatever it is. That's important to know, especially for this unit, okay? Especially for this unit where we're going in circles, right? In circles, are we changing the direction? For sure, because we're always going in a different direction. That's the big deal. All right, that was Newton's first and second law, the first half of it. There's another half of it though. What? It's the other part. If F net doesn't equal 0, then what do we know? It's accelerating. Yeah, it is. Acceleration also doesn't equal 0. We follow that up with a couple of other statements. We know that the acceleration is equal to the net force, and it's also related to something else. Do you remember? What's the other thing that's related to? Or net force is related to acceleration and mass. Yeah. So we write it like this. This is the way I really like to write Newton's first and second law, but sometimes we also write it as F net equals ma. And oh, by the way, I'm going to add one more little thing to this, and that is that if we're moving with uniform circular motion, the acceleration is a special kind of acceleration. It starts with a C. We have to be careful about which one we choose, right? Mia's like, I'm not even going to say anything right now because I don't want her to scream at me. It's true. Look back at your notes from yesterday. There was one that we wrote and one that we wrote and crossed out really vigorously. Which one is it? Which one is the good one? Centripetal? Yes, yes. It is. When we have uniform circular motion, the acceleration is called centripetal acceleration. Write that down. Write that down. When you have uniform circular motion, the acceleration that an object experiences is called centripetal acceleration, caused by a force. Okay? We've got about, I don't know, 5 more minutes or so before Mr. B is gonna bang down the door and tell me that it's time to do tests back. So I'm gonna keep cruising here. Once you've got that written down, you can put your notes kind of to the side and pull that purple sheet out, because we're going to use that purple sheet today to do some examples. Okay. Can I click over to my page? Is that okay? Does anybody need this still? All right. So standard 5.1 is worded very similarly to standards 3.1 and 3.2. Okay. I put them together because I didn't feel like they needed to be separate standards this time. So just a quick look up here. This is what you're going to be assessed on Monday. So just FYI, your quiz will look something like this, right? I can label a free body diagram with balanced and relate balanced to unbalanced forces when an object is moving in uniform circular motion. I didn't actually put that at the top of your page, and I kind of feel like I should, okay? But you might want to just write yourself a note. Hello. Write yourself a note that 5.1 involves free body diagrams, okay, in uniform circular motion. And I really just need to rewrite this. This is really just writing an F net equation. I'm going to do one practice one today. Maybe we'll get to 2. We'll see. We're going to look at the yo-yo that was on the floor. One of the funny things about uniform circular motion is you have this kind of like 3-dimensional thing going on. If I draw the yo-yo from above, gravity's pushing into the paper. How do you draw an arrow into the paper? Spoiler alert, there are ways to do that, but we're not going to do it today, okay? We're going to look at it from the side. So the way that I want you to look at this thing right here, I'm going to color my little dot pink just so you get that that's the yo-yo. So we're talking about the yo-yo, okay? on the floor. Actually, I'm going to write that up at the top in that little box that I put there for it. Oops, come back, stop. Yo-yo in a circle on the floor. Okay. And then I'm going to draw the string over here just so that I remember what's going on. So this is exactly what you saw yesterday. This is exactly what we saw in the video earlier today. What's one of the forces acting on the yo-yo? Can you tell me? What you got, Emma? Gravity. And if I'm going to be a really good kid and I'm going to write my free body diagram out really well, because we have to remember to do that, what force is acting on the yo-yo? The earth. Which way does it pull? It pulls down. Here we go. So we got the force of the earth on the yo-yo. Yo-yo. FG. Awesome. Any other forces acting on the yo-yo? Which way is the floor pulling or pushing? It's pushing up, right? Don't know why that keeps doing that today. Oh my gosh, seriously? It's ridiculous. I thought that I said it to fix it, but maybe not. The force of the floor on the yo-yo. And my easy way to write that is going to be F sub N. You got it. All right. And before it's spinning, that's all I got. But now when it's spinning in a circle, what else is acting on it? What's that? Tension. The tension is the force of the what on the yo-yo? Good job, you guys. You got this. I love it. Oops, like that. Does it make sense? I should have asked. I apologize. I totally overstepped my bounds there. Hunter, what direction is the tension force pulling in? All directions? What do you mean all directions? Because it's going, so it depends on where you look at it, right? So if I take a snapshot right here, which way is the force pushing? That way, right? So the game with string is that it's always going to pull along the string. Okay? So it's going to be the force of the string on the yo-yo. That is my tension force. How are we doing? Look at us, we did half of 5.1. We drew a free body diagram of the forces acting on the yo-yo. Oops. Are there any other forces acting on the yo-yo? I should have asked. Sorry, I'm just excited. We good? Okay. All right, we did half of it. Yay for us! All right, now, you notice these questions are here again. They're here because we want to make sure that it's making sense. Is the object accelerating in this direction? In the x direction. So remember, this thing is going around and around and around and around. Haley is like, yeah, it is. Is it accelerating? How do you know? I like that you like dance it out. Let's remind ourselves what accelerating means. We just said this before. This is why we did it, right? What does accelerating mean? Whoop. Change of velocity, which means that it's either speeding up, slowing down, or changing direction. Okay? Now, I'm just going to write that down here, and you might want to write it down too. So if it's accelerating, that means that it's speeding up, slowing down, or changing direction. And Haley, which one of those is the case in this situation? Ding, 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 ding. You got it. You got it. Yes, indeed it is. What forces are acting in the x direction, you guys? Just the tension, right? F sub t, just the tension. And that tension force is causing an acceleration. And that's a special kind of acceleration. What kind of acceleration is it, you guys? It is. Look at you using new words. I love it. All right, 3/4 of the way done. We got one more piece. Here we go. Is the object accelerating in the y direction? No, it's not speeding up, not slowing down, not changing direction in the y dimension. So that means we can say nope. What's acting in the y direction? Just got to look at your free body diagram. Yeah. The normal force and the gravitational force, right? Fn and FG. We might want to mark that FG is negative. Those two things have to add up to M sub A, or M times A, but A is 0. So we can say that this is equal to 0. Is that okay? It's not that much different than the stuff we did before. You guys got it, right? Okay. Tomorrow, yes, tomorrow we will continue with this. Do not lose that piece of paper. We're going to use that to take a bunch of notes this week. Okay? All right. I'm going to turn it over to Mr. B so that he can do tests with you all.